Dear students, hope you are enjoying the good health. We have almost completed all the methods of arithmetic mean, and today we will learn the merits and demerits of arithmetic mean. First we will learn merits of arithmetic mean. The first merit of arithmetic mean is that it is simple and easy to compute, easy to calculate. That is, it does not require ordering of data. No ordering of data. There is no need to make the sequence of the given data of a given series, such as ascending order or descending order. It does not require the conversion of data either into ascending order or descending order. No ascending order or descending order of data. Or we can say there is no need of giving ranks to a given data. In which form the data is given, we have to apply a particular formula of arithmetic mean to calculate its value. Now we will discuss second merit of arithmetic mean. The second merit of arithmetic mean is that it is based on all the values of a given variable. All the values of a variable. Or we can say it is based on all items of a given series, of a given statistical series. While calculating arithmetic mean of any given data of any given statistical series, we have to take all the values of the variable. No value of the variable is left out while calculating arithmetic mean of a given data of a given statistical series. This is the merit of arithmetic mean. And the third merit of arithmetic mean is that it is capable of third merit, capable of further algebraic treatment. Such as combined mean, as we have already learned how to calculate combined mean of a given series, of a given data. This I will explain with the help of some example. For example, a worker it may be male, female worker. If we calculate the average, for example, average wage of male workers and average wage of female workers. X1 bar, that is arithmetic mean or average wage of male workers, this X1 bar shows, and this shows average wage of female workers. When, for example, the average wage of male workers, it is equal to 50 and number of male workers, it is equal to 10, and average wage of female workers, it is, for example, given as equal to 40 rupees, and number of female workers, it is equal to 5. Or we can take average wage of male workers equal to 500 and average wage of female workers equal to 400. Now, from this related data, we can calculate combined mean. First, we have calculated the average arithmetic mean of male workers and average wage of female workers. Now it is capable of further algebraic treatment. It is subject to further algebraic treatment. We can further calculate the other values such as combined mean. And combined mean, as you know, it is equal to, so there are two groups, male and female workers, x bar 1 2, this is the combined mean of two groups, that is male and female workers. It is also known as grouped mean. It is equal to n1 x1 bar plus n2 x2 bar divided by n1 plus n2, and it will be equal to 10 into 500 plus n2 is 5, this is n1, this is n2, and x2 bar, it is equal to 400 divided by n1 plus n2, it will be equal to 10 plus 5, it will be equal to 5,000 plus 2,000 divided by 15. It will be equal to 7,000 divided by 15, and it will be equal to, the combined mean will be equal to 466.66. The combined mean, which shows the average wage of worker consisting of male and female workers. This is how we can calculate combined mean, and we are discussing the merits of arithmetic mean. That this third merit, which shows that this arithmetic mean, it is subject to further algebraic treatment. It is capable of further algebraic treatment, which is that first we calculate the average wage arithmetic mean of the first group and second group, then combined mean of both groups. The combined mean of both groups means subject to further algebraic treatment. I hope you have got it, and you can take many more examples on this, such as marks of girl students and marks of boy students, and then their combined mean. Now we will discuss one more merit of arithmetic mean. It is useful for making comparison. It is useful for making comparisons. We will take the same example, that is average wage of male and female workers. For example, average wage of male workers it is equal to 500, and average wage of female workers it is equal to 400. From this data we can compare between male and female workers on the basis of wages they get. We can interpret it that females they get less wages as compared to males on the basis of average value or income of two or more than two groups is given. And from that we can compare which one is rich and which one is poor on the basis of their average income. This is the merit of arithmetic mean, that it is useful for making comparisons. These were the merits of arithmetic mean. Now we will explain demerits of arithmetic mean. The first demerit of arithmetic mean is that it is affected by extreme value. For example, income of 4 persons is given as 2,000, 4,000, 5,000 and 21,000. And its arithmetic mean will be equal to sigma x divided by n. Sigma x, summation of the values of variable x, which is income in our example. It will be denoted by x and divided by total number of observations, total number of items in a given series. So this is the individual series. We have 4 persons. Income of the 4 persons, income of the 4 individuals is given, and it will be equal to 2,000 plus 4,000 plus 5,000 plus 21,000 divided by 1, 2, 3 and 4, the income of 4 individuals. The total number of observations, total number of items in a given series, they are 4. And it will be equal to 32,000 divided by 4, it will be equal to 8,000. This shows that the average income of these 4 persons, it is equal to 8,000 rupees. We can interpret in different ways. We can say that all persons are relatively rich. But if we look individually at these values, the income of these 4 persons, one person is getting only 2,000. He is also considered as rich based on the average income, which is equal to 8,000. And this has happened due to inclusion of this extreme value, which is equal to 21,000. Since 2,000, 4,000, 5,000 are almost near to each other, but this 21,000, when it is included in this data, and we get the result, that is average income, which reflects the position of all these 4 persons. Therefore, on the basis of this average value, we cannot interpret the exact meaning of a given value. We cannot reach to the meaningful conclusion. There will be wrong analysis of data when there is inclusion of extreme value, such as in our example, which is 21,000, which is the highest value as compared to these values. It also reflects the position of the person whose income is only 2,000. This is how arithmetic mean is affected by extreme value. Now, one more demerit of arithmetic mean is that sometimes it leads to or we can write, sometimes it gives misleading conclusions. For example, sales revenue of 2 firms is given, or we can say sales revenue of 2 producers is given as A and B. Year 2001, or we can write here year and sales revenue. in, in year 2000, for example 2015. Form 8 sales revenue is given as 1000 crore, and sales revenue of the firm B, of the producer B, in year 2015, in the same year 2015, it is equal to 2000 crore. And average sales revenue will be equal to that is arithmetic mean of this data is given as x bar is equal to sigma x, that is summation of values of variable x, which is sales revenue, divided by n, number of items. It will be equal to 1000 crore plus 2000 crore divided by number of items. Since there are two firms, therefore it will be n will be equal to 2, and it will be equal to 3000 divided by 2. It will be equal to 1500 crore. This is the average sales revenue of the two firms in 2015. Now, for example, the sales revenue of these two firms in 2016 is given as A's sales revenue is equal to sales revenue, that is revenue from sale of goods or sale of commodities, is equal to 2000 crore, and B's sales revenue is equal to 1000 crore. Opposite of this data we will take, and arithmetic mean x bar, it will be equal to sigma x divided by n, which is equal to 2000 plus 1000. Since this sales revenue, it will be denoted by x, where x is a variable, we show the sales revenue of the two firms, and there are two firms having their sales revenue in 2016 equal to 2000 and 1000. So there are two firms, the n will be equal to 2, and it will be equal to 3000 divided by 2. It will be equal to 1500 crore. The average sales revenue of these two firms in 2016, it is 1500 crore, and in 2050 it was also equal to 1500 crore. We can say that, we can interpret that there is no change in average sales revenue of these two firms during these 2 years, 2015 and 2016. But if we look into the data, we will find that the B sales revenue have decreased. It is sales revenue in 2015 was equal to 2000 crore. It have decreased to 1000 crore. Its condition is worse as compared during the year 2015. And A's sales revenue have increased from 1000 crore to 2000 crore. It is sales revenue have increased its condition. It is business activity have flourished, showing the opposite analysis of the data, which says that there is no change in their average sales revenue during these 2 years. It means that both are better off because there is no decrease in their sales revenue.